right, example 3 says to differentiate y equals e to the secant of 3 theta. So this one, since if I were just to have secant of 3 theta, that would actually be a chain rule. And since I have e to the secant of 3 theta, I have to chain rule not only once, but twice. Okay, so this is what I would say is a double chain. Okay, double chain rule. Got to do it twice. So our derivative. First things first is maybe let's figure out who's the big outside. The outside right here is e to the x. That's our out. And then this would be our inside, the secant of 3 theta. So what we do is we take the derivative of our outside, which is the derivative of e to the x is e to the x. So it's e with our original inside plugged back in, 3 theta. Now I would multiply it by the derivative of my inside, which is this part. Okay, well, this is actually another chain rule because I have my outside is secant and then my inside is 3 theta. So what I'm going to do is, well, take the derivative or chain rule again. What is the derivative of secant? The derivative of secant is secant tangent. So it'd be secant with our original inside, 3 theta, tangent with our original inside, 3 theta, times the derivative of this inside. The derivative of 3 theta would just be 3. Okay. So let's maybe quickly walk through this one more time. So it's a double chain rule. So my first outside is e with the inside of secant of 3 theta. Okay, so the derivative of my outside is e to the x. So it's e to the x. So it's e with our original inside plugged back in. Now you need to go ahead and take the derivative of this inside piece. Well, the derivative of a secant is secant tangent, okay, with our original inside 3 theta. And then we would take the derivative of that inside. The derivative of 3 theta is just 3. And then I would just go ahead and rewrite this, put that 3 in front. 3 e to the secant of 3 theta, secant of 3 theta, tangent of 3 theta. And that would be your answer for example 3.